Thank you, Teddy. So welcome, everyone. We're so delighted that you could join us for today's talk, the MENA methodology, ARCH's remote sensing, GIS, and archaeological change detection with Dr. William Deadman. So today's talk is the second in a series of, actually the third now, isn't it, in a series of seminar presentations that we have called GIS from the ground up, introducing geospatial tools for archaeological research. If you didn't join us last week, during the next few weeks, we will have different scholars of archaeology, heritage, and or GIS in the South Caucasus presenting on different GIS techniques, focusing on how it contributes to their research. We welcome audience members at all levels of GIS experience, but the aim of each presentation is to introduce scholars unfamiliar with geospatial methods to the anatomy of a GIS-focused research project and elements of GIS research design through real-world case studies. So our seminar presentation next week will feature Dr. Emily Hammer from the University of Pennsylvania, who will discuss landscape scale analysis using least cost paths. So you can register for that seminar on ERISC's website, www.erisc.org. So before we get started, we want to acknowledge that the series is co-hosted by the American Research Institute of the South Caucasus, ARISC, the Endangered Archaeology in the Middle East and North Africa, EAMENA project, and the National Agency for Cultural Heritage Preservation of Georgia. The funding for this series is provided by the U.S. Department of State's Bureau of Education and Cultural Affairs through a grant to the Council of American Overseas Research Centers. So I now have the pleasure to introduce today's presenter, Dr. William Deadman. So Will is a postdoctoral research associate on the Endangered Archaeology in the Middle East and North Africa project at Durham University in the UK. He did his PhD also at Durham, looking at the distribution of Bronze Age tombs in southeastern Arabia, and he's done extensive field work in Oman. His research interests include the use of GIS and remote sensing in archaeology and the landscape archaeology of Arabia and the Middle East. So without further ado, please join me in welcoming Dr. William Deadman.
Thank you very much. Let me just share my screen. There you go. Hopefully everyone can see that. Yeah, thanks very much for the kind welcome. As Kristen said, I'm Will Deadman, so I'm a postdoctoral researcher with EAMENA at Durham University. And I'm going to be talking about how the EAMENA project works, especially with geospatial data, and in particular, looking at ARCH's remote sensing, GIS, and change detection. I'm going to be covering quite a lot of ground over the next 40 minutes or so. I'll start with a bit of background about the project and then move on to talk about the EAMENA database, which is obviously central, and then the remote sensing methodology that makes up the core of our data collection. And then I'll move on to talk about some of the other ways in which we collect geospatial data, and I'll also introduce how we monitor archaeological sites. And talk a little bit about the methods we've developed to do this remote automatically, mostly with Google Earth Engine. Right, so just first a bit of background on the project. So EAMENA stands for Endangered Archaeology in the Middle East and North Africa. Why is this relevant to the South Caucasus? Clearly, they fall outside of our area. Well, the geospatial methods and the general approach that we use are relevant anywhere, really. And we have also been collaborating with partners within the South Caucasus to apply some of our methodologies there. You can, if you want to find out more about my talk, after my talk, you can find out more on our project website, EAMENA.org. The project was originally set up in Oxford University in 2015 in response to the damage being done to heritage in the region by ISIS and wider damage as well. It was later expanded to include wider expertise from Durham University and the University of Leicester. Along with my other colleagues and the volunteers, including Kristen, who I'm sure you know, we focus on mainly on at Durham, we mainly focus on Lebanon, Syria, and Iraq, with universities of Oxford and Leicester covering other parts of the Middle East and North Africa. EAMENA's aim is to record and evaluate the status of the archaeological landscape of the Middle East and North Africa, or MENA, and in doing so to create an accessible body of data which can be used by heritage professionals globally, specifically by targeting the most threatened sites in order to better protect heritage across the region. So sounds great, I hope at least, but how are we actually going about it? Well, by identifying and monitoring MENA's endangered archaeology, by creating a record of sites for each MENA country, crucially by training and empowering local partners in the region, and by making our data as freely available as possible, ultimately, hopefully by helping to protect and conserve MENA's archaeology. Also important to mention where the money comes from that allows us to do this work. Arcadia is our main funder. They also fund many other similar projects as they see preserving endangered cultural heritage as a key part of their mission. Other parts of our project, especially our training, have been funded by the Cultural Protection Fund, the British Council and DCMS, and other parts of the project have been also funded by ARLIF. EAMENA has been going since 2015, but since then there have been an explosion of similar projects using similar methodologies to achieve similar goals, but in different areas. And we hope that the EAMENA project has been sort of an inspiration or a bit of a trailblazer in this area. Our database really lies at the core of our methodology. Really, it's the foundation of the project. Rather than a traditional relational database, which I'm sure many of you will be familiar with if you've spent as much time pulling your hair out over Microsoft Access as I have. Unlike that, our database is graph-based. I'm not a database engineer, but this means that it focuses much more on the relationship between records rather than fitting into the sort of rigid schema of a relational database. So the relationships are as important as the records themselves. It's a web-based database, which obviously means it can be accessed anywhere in the world that has an internet connection. And it's built using Arches, which is an open source, freely available software platform. And it's designed specifically, Arches is designed specifically for cultural heritage organizations to manage their sort of geospatial heritage data, funded by the Getty Conservation Institute and the World Monuments Fund. Our database currently uses uses the current version of Arches, which is 5.1, and this includes both a web and a mobile platform, which I think is new for Arches 5. Arches basically contains all the code and the tools and the building blocks you need to build a heritage database. But you can obviously customize it to fit your project or organization, and obviously you can find out a lot more than I can fit here at the Arches website. There's also a Demi Arches 5 database that you can test drive. And although it is designed to run off a server as a web-based platform, you can also install Arches locally on your PC relatively painlessly. I'm no programmer, but I was able to install it and mess around creating my own custom local database fairly quickly just on an old laptop. So definitely worth thinking about if you're running a new survey project or something. It's a really useful geospatial tool for managing data, so do take a look. I'm going to give you a bit of a tour of our database just to show you how we manage our geospatial data and to give you some idea of the capabilities of a relatively sophisticated Arches database. This is actually the third version of the EAMENA database. Earlier ones used previous versions of Arches. And we're now in the process of providing customized clones of our database to partner agencies in Palestine, Jordan, and Lebanon. A really good thing about Arches is that, and our database, is that you can have a public version and a full version. So with a public version, anyone can create an account and see basic site information and locations, and then researchers can apply for full access to see all the data. And this is really about being as open as as open with our data as is practically possible. Obviously, we don't want to provide. There's some difficulties in that area, but we try to be as open as we can with our data. So this is the search interface showing the 163,000 sites that we currently have in our database. And if you were to search for a particular site, such as the World Heritage Site of Anjar in Lebanon, for example, the public version would give this restricted location information, this restricted map of the site, while the full version with researcher access allows you to zoom right in to see the sort of the detailed location, and also to actually look at the remains of the site with the satellite imagery based map. The database is structured around different types of resources. So let me get my laser pointer. Yeah. So heritage places, these would include, these are sort of obviously our focus, but these would include archaeological sites and historic buildings. Information resources, such as are just all the data sources that we use, that we get our information from. So these could be publications or photographs or satellite imagery or maps. Person organization includes both the people creating the records, but you can also include, for example, historic figures with links to sites such as, Saladin or Genghis Khan or whoever, and you could also include agencies or organizations. Geoarchaeology allows us to record things like paleo landscapes, maybe old river channels, but then right down to sort of soil cores or other geoarchaeological samples. Built components allow us to record individual parts of sites or buildings in a great level of detail. So, for example, you could record just the outer wall of a site or the gateway of a castle, that type of thing, with built components. Detailed condition assessments allow us to carry out really detailed monitoring of a heritage place or a built component, and you can have as many of these as you like linked to either of these, so that you could repeatedly visit a site or part of a site and carry out, say, 6 monthly condition assessments. Finally, the last type of resource is just grid square. So this is just a customized lat-long grid that we use in our remote sensing survey, which I'll talk about a bit later. What's also crucial in the database, obviously, as I've touched on, are the relationships between these resources. So linking, for example, heritage places to other heritage places, or the information resources where the data came from to the heritage places, or the people that did the survey, just as some examples. And this can be done, the strength of a graph-based database is that this can be done very flexibly. So you don't need to conform to a really rigid schema as you would in some relational databases. It all sounds quite abstract, so I thought I'd provide a couple of examples just to illustrate how we record sites. This is the site of Burj Al Saigi, which is an isolated mud brick tower in northern Oman, where I've done some survey. You can see it there on the satellite imagery and obviously on the site photo. But just to stress, there's no sort of right way to record a site, but this would be a reasonable option based on the information that I had available. So you'd have a heritage, this is the main heritage place where all the information, all of the archaeological information would go. And then you have information resources for, say, the Google Earth imagery that we've already seen, and a separate one for the photo that we've seen, and maybe you could have a third one for the site report or something like that. You could then have a detailed condition assessment of the site, looking at the condition of the site and possible disturbances, that sort of thing. And then you'd have a person organization record linked to both of these things as the person creating these records. So that's a simple site. And also bear in mind, this may be a simple example, but it needn't be this complex. It can be simpler as well. But for a more complex example, this is another late Islamic site in northern Oman, one of the old capitals of Oman, actually, which is Old Rustak. And you can see this is the site here. There's a large late Islamic fort. There's a monumental tomb on the hillside, and then there's these mud brick buildings here. Again, how we choose to record it is entirely flexible. Here I've chosen to split it into 3 different heritage places. So Old Rustak as a whole for the whole of the site, a separate one for the fort, and then a separate one for the monumental tomb. But you could record it in any number of ways. So the parent heritage place of Old Rustak would be linked to both the tomb down here and to the fort. And then you also have a detailed condition assessment for the tomb, information resources linked to these heritage places. And then for the fort, maybe built components for the wall, separate built components for the wall, the gate and the towers, etc. And you could have multiple, one or more detailed condition assessments attached to just these built components. Again, just this, there's many ways of doing it. The database is flexible enough for you to be able to record the same site in any number of ways. This is just a working example. In terms of actually adding the info to the database, we try to avoid free text as much as we can, and instead we use detailed, restricted terminology in drop-down menus. And so we have sort of detailed glossaries to go with this in order to minimize any differences in interpretation or in the language that we use to describe features of a site. This makes it much more, the advantage of this is that it makes it much more user-friendly working between different languages, as it's possible to search for the same terms, say fort or whatever, in English or Arabic in our database, and it would come up with the same sites. So language isn't a problem. The way it works is that related fields are all grouped together in Arches 5 in cards, so that you're filling in similar information at the same time. I'll show an example of this. So for a heritage place, in this case, this is Byblos Castle in Lebanon. You can see the fields are grouped into 7 different cards. So you've got an assessment summary, which is just information about who, what, and how and when the information was inputted. A resource summary, just with some very basic information. And then geometries, either points, lines, or polygons with certainty values and that type of thing. And then geography about other location information about the site, obviously the country and maybe the administrative area, that type of thing. And then archaeological assessment, where the detailed archaeological information goes, as well as an environment assessment about the environmental context of the site. And then condition assessment, so some information about the condition of the site and if there are any disturbances or threats to the site, to the heritage place. So if we expand, for example, the archaeological assessment card, you can add all, there's more sort of subgroups in which you can add all this information about the site. So the archaeological certainty, the shape of the site, the periods of the site, and then all you can site features, which I'll come on to, as well as measurements and material and other stuff as well, anything related to the archaeology. You can add as many site features as you like. It's true for most of these forms, most of these cards. And you can see here, it's a fort, castle. It's the interpretation certainty is definite, and there's one of them. So this is typical of the way the database works. Again, we use drop downs throughout the database, so you have to find or search for the right term you're going to use, maybe using a glossary as well. The big advantage of using restricted terminology and using drop downs is it makes searching and querying a particular strength of the database, which is useful when there's more than 150,000 records, which is where we are at the moment. So you can search for free text, as here for Byblos. It'll just search any free text or any terms that match in the database. But you can also search for specific concepts, so the specific terminology that we use. So in this case, I've searched for tomb, grave, and burial, and it's narrowed the 150,000 records down to 15,000, so about 10%. About 10% of the heritage places that we've recorded are some sort of burial archaeology. You can also use advanced searching to build much more complex queries. So in this case, classical temples in Lebanon, you can build much more difficult query, much more complex queries than this, using EPID and all sorts. But it narrows it right down to just the 8 sites that we have recorded at the moment that fit those criteria. You can also use the map on the screen to draw your own filter, your own sort of geographical filter, region of interest, to restrict results even further, which is obviously really useful when you're dealing with large amounts of geospatial data. Right, so I've given you a really quick tour of the database, but what I also wanted to talk about is where we get all this data. Firstly, I'm going to talk about the remote sensing survey, which is really the backbone of our data collection, and it's also applicable, you know, not only in the South Caucasus but far beyond the MENA region. It provides a really rapid means of collecting data from anywhere in the world, and it's also obviously a safe means of collecting data, which is significant given all that's been happening in the Middle East over the last few decades. It also allows for really easy site monitoring, so you can make repeated remote visits to the site at very little or no cost. It's also particularly useful in the Middle East because of the low soil cover and the low levels of vegetation, and the lots of sunny weather and few clouds, which make it highly suitable for the region we study. However, there are some downsides. You need to be able to obviously interpret satellite imagery, which does rely on experience, which I think anyone can learn, but which takes time to build up. Also, a really effective survey relies on the availability of good quality, high resolution imagery. And although there is lots of easy to use and freely available software available, it will of course require some training, as well as normally a good internet connection as well, which obviously does restrict it to some extent. Most of our remote sensing survey uses Google Earth Pro, and this streams sort of pre-rectified high resolution imagery to the user directly without having to muck around with the more complicated image processing. And in fact, there's almost always more than one set of imagery available to view for any given area, which I'll talk about a bit more later. And as far as GIS software goes, it also has a really friendly user interface and is relatively easy to use, and it doesn't have the very steep learning curve that some GIS software does have. It's also free, which is obviously a massive plus, especially given how expensive some GIS software can be. To facilitate our survey, we use our own grid based on latitude and longitude, and that stretches right across the Middle East and North Africa. And these form the sort of basic units of our remote sensing survey. We tend to survey one of these squares at a time. That's how we sort of do our work. And these are 1/4 of a degree across, or about 25 kilometers, depending on where you are in the world. And then depending on the geography of the area we're surveying and the nature of the archaeology in that area, we tend to zoom right in, covering maybe an area of about 500 meters or 1 kilometer wide, and then just systematically move up and down and across the square, covering all of the imagery and marking any sites we find as we go. So here, for example, is a prehistoric cemetery of stone tombs on a range of hills. So I've found it and drawn around it with a polygon in Google Earth Pro, and then I just give it a sensible name based on the name of the grid square. And then we save these as separate KML files. Then they can be uploaded directly into the database. So we create a new heritage place record, and then fill in all the details we can, that this is probably a tomb of unknown date and that sort of thing, where it is, all that information I showed you. And then you can upload that polygon straight into the database as a KML file. So a significant proportion of our data comes from sort of new remote sensing survey like that, but we also rely on other sources too. So published archaeological data and maps are invaluable, as they represent ground-based data that we can be sort of more certain about. There's always going to be some uncertainty when you're doing remote sensing, no matter how experienced you are. We also use historical imagery, which Kristen's already talked about in a previous lecture, as well as legacy data collected in past research projects at Durham. So for example, this is one of about 130 maps published as part of an atlas of archaeological sites in Iraq by the Department of Antiquities in the 1970s. And we used GIS obviously to georectify each of these maps and then digitize the location and the site names, and then attempted to locate them on the ground using Google Earth and other imagery. And this is a great way of showing how many sites, not only a shortcut of finding sites, but also showing how many had been destroyed in the last 50 years or so, and a significant number we would never have spotted in Google Earth because they've been built over or they've been plowed. All these sort of things are a really valuable resource. There are also obviously archaeological survey maps from past projects. So this is from Adams 1972, a CAD survey. And we can combine not only the geospatial information for each of the sites, but also look through the site gazetteer and take all the name data, the site area data, the period data, and all of that can go into the database as well. As well as modern high resolution imagery like on Google Earth, as I've showed you, we also use historical imagery. Usually this consists of US space photography that's been declassified, including corona imagery and in this case KH9 around Eridu in southern Iraq. And this imagery is amazing because it allows us to map sites that have either been destroyed in the last 50 years or that have been degraded, to show us so we can see how the condition of these sites and the pressures on these sites has changed over the last 50 years or so. We've also been working with digitizing aerial photographs of Syria from the 1960s. These can be used not only in a similar way to the corona or the KH9 to find destroyed and damaged sites, but also we're also working out a way of using them to create historical digital elevation models. So this would make it even quicker to find a quicker way of finding sites, and also assessing how for example, have been eroded over time, that sort of thing. And in fact, we're about to start a project with Yorgi at the Georgian National Museum, helping to scan their archive of aerial photos taken during a similar period between the 50s and the 80s. Durham has a long history of researching the Near East, and so we also have a lot of legacy data from past projects. So rather than sort of reinventing the wheel and surveying these areas from scratch, we can adapt this data in order to be uploaded directly into the database, which is obviously a win-win, saving us time and yeah, with a lot of the work having been done for us. And the really great thing about the database is that all of these different diverse sources of data, geospatial data, can be recorded and linked to sites individually as information resources in the database. So whether aerial photos or published data sets or maps, it's possible to record all of these in detail and link them to our heritage places, to our sites. We've also developed a way, when you're working with large volumes of data like this, either from past surveys or legacy data, we also need a way of getting data into the database more quickly, as it would take a long time to add these sites one by one. But we use a special Excel template, which means that we can upload hundreds or even thousands of sites into the database at a time, with very careful data entry, which works really well and obviously saves a lot of time when you're dealing with large volumes of geospatial site data. Wherever we got the data for a site and however we got it into the database, remote sensing allows us to monitor the condition of these sites over time. So especially valuable for this is Google Earth Pro, and in particular the time slider tool, which allows the user to look back through older imagery, so you can go back in time essentially. So just an example, this is another prehistoric cemetery in northern Oman. You can tell what I did my PhD in. You can see individual tombs there in the inset window, and so you can see it's a massive cemetery covering a really large area. This image is from May 2009, and I've added the location of individual tombs just to make it easier to see. So if we move forward in time a bit, 5 years, you can see some new disturbances. So you can see new tracks having been put in. I'll go back, already doing some damage to the site in 5 years. And then also down here, hints of maybe something worse to come. And yeah, so by a year later, this has got more drastic, and you can see that already a number of these tombs have been destroyed. And then 6 months on, you can see the full extent of the damage that's going to be done, at least. Not only a large highway, but also a junction being put right through this this cemetery, with work being pretty well complete by May 2018, with dozens of these tombs that were mapped, destroyed, or damaged. And although we can't stop this damage happening, the great thing with Google Earth Pro is that we can sort of quantify the damage that's being done and also place it accurately in time, with Google Earth images generally available every few months or so, at least for this part of Oman. Google Earth Pro isn't the only resource we have at our disposal to do this sort of work. We also use planet imagery, which is lower resolution, I think around just under 3 meters, something like that, but is updated much more regularly, which is a great resource to have when you're trying to map when a particular disturbance was happening. As well as lower resolution multispectral imagery, as well as planet imagery, sorry, we also have lower resolution multispectral imagery, such as Landsat and Sentinel-2, which are easily accessible through Google Earth Engine and are really useful when working at smaller scales or covering larger areas, although less so for sort of smaller sites. And this all sort of leads into a major part of our work in the EAMENA project, which is monitoring disturbances and threats to archaeology. These are obviously manifold and varied, but there are some that we tend to see again and again in our work. Some you're likely to have heard about in the news, such as conflict and looting. But in general terms, these are secondary in terms of the amount of damage being done, at least, to the more mundane threats, such as agriculture and construction, which are a real problem, obviously everywhere in the world, but especially in the Middle East, as far as we see. There are also natural disturbances, such as weathering and erosion. And although we call them natural, they're almost certainly exacerbated by the more extreme weather that's occurring due to global warming, which I'll talk to you about in a minute. So just a few examples. This is the sort of classic example that many people will be aware of, the Temple of Palmyra being blown up by ISIS in 2015. And this is the after shot with the temple completely flattened. But as well as that sort of deliberate destruction, sites are also highly susceptible to sort of collateral damage in conflict. So this is Kahira Fort in Yemen in December 2014. And then again in June 2015, following an airstrike, the main part of the building almost completely flattened. In terms of looting, this is the site of Dura Europos in Syria before and then after years of systematic looting by Islamic States to fund their activities. The site completely dug over, covered in these pockmarks, looting holes. As I say, even more serious perhaps is the expansion of agriculture that's occurring across much of the Middle East. So this is one example. These are the official UNESCO World Heritage Site boundaries of Samarra in Iraq. And you can see using this Landsat 5 imagery and this Sentinel-2 imagery, just how much agriculture has expanded, even within the boundaries of the site in the last 30 or 40 years. So a massive problem even in an important site such as Samarra. This is a less well-known site, at least a smaller site. You can see that these tells in southern Iraq are literally being threatened on every side by agriculture. You can see the ploughing around the edges, which will be slowly eroding parts of the tell. You can see the irrigation channels being cutting through the low-lying parts of the site. and the sort of tracks and the buildings being put up to support farming. You can also sadly see, at least on one of these tiles, evidence of looting as well. There's also huge pressure from urban expansion and the construction of infrastructure. So here you can see how the city of Mosul has sort of expanded inside the ancient walls of Nineveh, and is also surrounded, obviously, on every side by the city. Similarly, pressure's being put on the UNESCO Roman World Heritage Site of Jerash in Jordan, surrounded by the modern town on every side, and ironically with tracks and infrastructure being added to cope with the huge number of visitors to the site, which is obviously another form of disturbance that we can record in the database. Tell sites, which are common across much of the Middle East as well as elsewhere, they're particularly vulnerable to erosion, and this damage is clear to see here with the gullying cutting right through the old mud brick. It's also very clear on high-resolution satellite imagery. So this is an apparently sort of natural phenomenon, but what's clear is that this is only going to get worse as global warming leads to more extreme weather. So you can imagine what drought conditions followed by violent rainfall is going to do, like a site do for erosion at a site like this. It's going to get much, much worse. With rainfall so low generally across the Middle East, water is obviously a precious and limited resource. But you end up with the double whammy of not only sites, reservoirs being built, dams being built, and reservoirs being developed to hold water. Flooding archaeological sites such as these tells in Lake Hamreen in Iraq. But also, as the water levels dwindle and as pressure is put on water, these sites are actually exposed to the open air and are particularly susceptible, much more so than they were before, to erosion from this drying, this inundation and then drying and weathering. To keep track of all these disturbances and threats, we carry out condition assessments on sites, and these allow us to monitor and record their condition over time. At the very simplest level, this can just be a single assessment of the condition of a site, from good to fair to poor to very bad and destroyed. And here you can see how these are all the sites with the condition in the database, and you can see how poor, very bad, and destroyed sites make up nearly a quarter of all sites in the database. But we can also record the horizontal coverage of damage, the damage extent. So, for example, if half of a site is built over, or a quarter of a site is bulldozed, we can record that, the extent, the horizontal extent of the damage. But we can also record the details of individual disturbances to sites. So I'll give some examples in a minute, but the sort of type of disturbance, the category of disturbance, or what's causing it, as well as the effects that the disturbance is having on the site and when it happened. So, for example, this is a map of the condition of historic buildings near Beirut port prior to the explosion in 2020. You can see generally they're in a good or a fair condition. And then this is their condition after the explosion. We were able to work with the DGR team on the ground in order to record this data. And obviously, in this case, the massive degradation of the condition of these buildings can all be tied to the same disturbance, the explosion, which we could pinpoint to a specific date and time and record in the database. And as you can imagine, with so many sites in the database, as I said, about 150,000, we haven't been able to carry out condition assessments on all of them by any means. But this shows the disturbance data that we have been able to collect, thousands of instances across much of the Middle East and North Africa. And just to give you some idea of what we can do of this data and what we can do with it. So we record, as I said before, we recorded the types of disturbance, which is the sort of general category that's causing it. So at the moment in the database, agricultural and pastoral disturbances are the most common, accounting for nearly a quarter of all known disturbances, followed by natural, infrastructure and transport, and building and development. These are just the top four. I haven't included all of them. And then we also record the causes of the disturbance, which is the specific thing that's being done that's damaging the site. So these are just the top three from agricultural and pastoral. So these include clearance for bulldozing to basically expand fields or to get things out of the way of the edge of fields, vegetation or crops being grown over the top of sites or near sites, and then ploughing being done over the top of or around the edges of sites as well. These are all different causes that we can record in the database. And then finally, we have the effects. So this is this is the effect that this is the negative effects that are being had that the site is suffering from due to these causes. So in this case, these are from ploughing, and we record these as too, obviously. So ploughing, in 40% of cases, there's earth displacement. There can be collapse or structural damage to the site. There can be the displacement of artifacts, and it can cause further erosion and the deterioration of sites. So this is how we record disturbances in the database. As I briefly mentioned before, as well as this fairly rudimentary condition assessment data that I've just described, we can also do much more detailed condition assessments for heritage places or even built components. And these are a separate type of resource. All that data I was just showing you is actually recorded within heritage places, but you can do a much more detailed version if there's a particular site or a particular part of a site, a built component of a site that you want to record in great detail. And you can add as many of these as you want over time. So you could do a 6-monthly check of a particularly vulnerable site or that sort of thing. Or repeated ground visits for our partners in the Middle East that are managing these sites. So you can record those in great detail. Yeah, so for example, you could have a detailed condition assessment for the tomb, as I said before, or for the built components of, say, parts of the important parts of the site, important components such as the wall or gate or whatever. Very briefly, the project is also involved in developing methods for the automatic monitoring of sites. So this wouldn't rely on manually revisiting each site on Google Earth. You can see with 150,000 sites in the database, we simply don't have the human resources needed to do that for every site. But instead, we're developing ways in which you can automatically check and flag up any sites which may have seen significant change over a defined period. For this, we've been using Google Earth Engine and Sentinel-2 imagery. And in this script, you can see we've inputted these sites, the yellow and green markers covering this area. And then the red areas on the raster are basically areas where significant change has been detected between an earlier and a later Sentinel-2 composite. And then the script automatically compares that with the site boundaries and highlights any sites with change inside them. In this case, you can see a red dot there that probably relates to an alteration of a building or an extension of a building, that sort of thing. So yeah, a way of automatically detecting change. Details of this part of the project were recently published in Remote Sensing in an open access paper. So if you're interested, do feel free to have a look and find out more. There's also included in it is the Google Earth Engine script, which can be adapted to other areas, obviously beyond those looked at in the paper. And our colleagues at Leicester were able to build this script and then test their results on the ground, detecting all sorts of disturbances automatically, including flooding and bulldozing and dumping and all sorts of things. And after using local partners on the ground, they were able to test the accuracy, and they found that it was over 85% accurate. But this is an area that we're going to continue to work on and continue to develop, hopefully to expand beyond our own region of interest. Right, so thanks very much for listening. I hope that some of that was useful or interesting to you. I'm obviously very happy to answer questions, but do also check out our website, EAMENA.org, if you'd like any further information.